Example 11 talks about the Blue Book. Okay, a Blue Book tells you approximate prices for used vehicles. Okay, so if we have a Blue Book that was from 2009, and we were looking at the value of what a 2006 Ford Mustang Coupe should be, the Blue Book tells you that the value for that kind of a car should be $13,015. But we looked at some of the asking prices for various 2006 Ford Mustangs in the Phoenix area, and we got 10 different asking prices based on their quality and things like that. Here are the information here. This question is asking us at the 5% significance level to test if the average price for the average asking price is, see if it's less than what the Blue Book value says that it should be. Okay, so here we've got some sample raw data. We've actually got the actual sample values themselves. What we'd like is to find some summary statistics about this. Remember, the two things that we'll be interested in here are the mean. Okay, so the mean, what we do is just take the average of these values, starting with this first one, 13,645, and we want to add up all of these 10 values all the way to the last value here, which is 12,765, and then we would just simply divide by how many, which is 10. And if you did this, it might take you some time, but you would find that this average here is $12,601. The other statistic, the sample statistic that we'll need, is actually also the sample standard deviation. This is going to be a little bit more difficult to calculate. Remember, sample standard deviation is denoted with an S, and the formula for calculating it looks like this. Okay, so there's the formula. Try and remember how this works. We need to take each of the value, subtract it from the average, then we're going to square them, add them all up, and divide by n minus 1, finally taking the square root. So basically we would take the first value, which is 13,645, subtract the average, which is 12,601, find the difference and square it. And we'd want to do that with every one of these values all the way up to this last value here, 12,765. Subtract this average, 12,601 squared. And then we want to divide by how many data points there are, subtract 1, and finally taking the square root of that. Okay, so that's going to take you quite a bit of time if you have to do this by hand. Of course, I'm going to show you how to do this by Minitab later, but this is how you would do it by hand. The sample standard deviation would end up being 877. Okay, so first to do a test, what we need to do is to set up our hypothesis, to find the H naught, or the null hypothesis, and the HA, or the alternative hypothesis. We're testing to see if an average, okay, so we're testing an average, we're testing if mu here is less. Okay, so the sign for less is this sign here. Notice it's less than, not less than or equal to. There is no equivalency here, so because there's no equal sign, then we know this is the alternative sign. Okay, so here mu is less than, we're trying to test if mu is less than the value found in the Blue Book, which is 13,015. Okay, and so if the alternative sign is less than, then the null hypothesis sign must be greater than or equal to. Okay, so here are two alternatives. You can go ahead and draw a picture for this. Okay, so here's your curve. This is a lower tail test. Here's where H naught is. Remember, greater than or equal to. This is the greater than or equal to side. And HA is over here in the less than side. Okay, here, because we have S and not sigma, because we have the sample standard deviation and not the population standard deviation, we should be using a t-test. Okay, so to find this t-test, remember we find the test statistic with this formula, x bar, subtract the hypothesized mean. Okay, so there could be sub-zeros here, meaning these are the hypothesized means. X bar subtract the hypothesized mean divided by sample standard deviation, which is over the square root of n. Okay, so x bar is the average that comes from our sample. Okay, so here when we took our sample's average, we found it to be 12,601. Subtract the hypothesized mean. You'll find that mean in the hypothesis. That's 13,015 divided by the sample standard deviation, which we found to be 877, and divide by root 10. Here we'll get a sample, a test statistic of approximately negative 1.49. Okay, what we need to do is to find the p-value so we can make a decision about our hypothesis. Okay, finding p-values by hand for t-tests are a little bit difficult. Okay, so what we need to do is to go to our t-table. Okay, remember t-tables, you've got degrees of freedom down the side. Here our degree of freedom, remember for a t-test, a degree of freedom is always n minus 1. Okay, so that would be 10 minus 1, or 9. Okay, so the degree of freedom that we're playing around with here is 9. And we want to find this value, this 1.49, in this row and see what happens. Okay, so if you go to your t-table, you'll notice that you'll find the number 1.383, and you'll also find the number next to it to be 1.833. We're looking for 1.49. I know that it's not there, but it is in between these two values. Okay, so then I will look at the corresponding tail probabilities that this t-table gives me. They will be 0.1 and 0.05. Although I can't say exactly what my p-value is, because I don't have that value, that 1.49 value showing up on my t-table, what I can say is that it must be between these two values. Okay, so my p-value is somewhere bigger than 0.05, because it's definitely bigger than 0.05, but yet it is smaller than 0.1. Okay, so my p-value is bigger than 0.05. Notice here that my alpha is 5%. My p-value is bigger than 5%, right? So here's 5%. I know that I'm bigger than that because my value was actually in between these two. So the p-value must be greater than alpha. In this case, anytime your p-value is greater than alpha, then you will fail to reject H0. Okay, basically what I'm saying here is that the evidence is supporting, not necessarily making it true, but supporting the idea that the average price that people are asking is actually greater than, greater or equal to $13,015. Okay, so let's show you how to do this on Minitab, because Minitab can be quite a bit more easy to use. Okay, in Minitab, because we have raw data in this case, I typed in all of those 10 values for the Ford Mustang asking prices. Okay, remember if I wanted to get the sample information like the sample mean and the sample standard deviation, I could do that by going to Stat, Basic Statistics, displaying the descriptive statistics of the column 1 here. So I'm going to put my variable column 1, and then I want to make sure that I have the mean checked off as well as the standard deviation. None of these other things need to be checked off. All I'm trying to find here is the sample average and the sample standard deviation. See, and you can see that when we calculated it, we got the same values that they did. Okay, to actually complete the test here, we can do that by going to Stat, Basic Statistics. a one sample t-test. Okay, my sample are in columns here. All my data here is in a column, so I do want to check off the sample in columns. The column that I put my information in was column 1. I want to perform a hypothesis test where the hypothesized mean was $13,015. Make sure to click off the options here. You want to be 95% confident, which means alpha is 5%. That is the leftover percentage. And in the alternative, remember, our sign for the alternative was less than. Let's just check. Here's the alternative, and the sign is less than. OK, and OK. Here it's telling me that my t-value is negative 1.49. That is the same test statistic that I calculated by my formula. And here the advantage of a computer is it can give us the exact p-value. We knew by the table that our p-value was in between 5 and 10%, and here we can see that it is exactly 8.5%. Okay, so the p-value is 8.5%. That is greater than alpha. We will arrive at the same decision to fail to reject the null hypothesis, or to, in layman terms, say that the null hypothesis is being supported by the data.